North Tunisia, February 20th, 1943. Inside their Panzer IFOs, German tank commanders froze. What they were witnessing was impossible. 5 American Sherman tanks, separated by hundreds of meters, no line of sight between them, swallowed by desert dust and smoke, moving like they shared a single mind. No flags, no flares, no dispatch riders racing between vehicles, yet each tank covered exactly the blind spots of the others. Each crew knew precisely where their comrades were positioned. They converged on German positions with timing that seemed supernatural. Inside the Panzers, Germans screamed into their Fuji-5 radios, cutting-edge technology from the 1930s. But all they heard was suffocating static. Their 10-watt transmitters barely reached a few hundred meters. Most tanks only had receivers. They couldn't report what they saw, couldn't call for help, couldn't warn anyone. The Americans were operating with something the Wehrmacht didn't even know existed. Invisible, silent, lethal. And in that moment, 5,000 miles from Detroit's assembly lines, the most decisive technological advantage of World War II wasn't in armor thickness or gun caliber. It was in the invisible electromagnetic waves connecting every American crew in ways the Germans never imagined possible. The transformation began on July 22, 1941, when the United States Army standardized the Signal Corps radio sets SCR-508, SCR-528, SCR-538 for all medium tanks. While German forces were advancing through the Soviet Union using tactics that depended on radio communication between command vehicles, American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting frequency modulation technology that would render German systems obsolete. The engineering team included Daniel E. Noble, who conceived the application of FM technology in military vehicles, and Henrik Magnuski, the principal RF engineer who solved the technical challenges of installing sophisticated electronics in the harsh environment of a tank. Their creation weighed 181 pounds and transformed every Sherman into a node in the world's first battlefield network. The BC-604 transmitter generated 25 watts of power, 2.5 times the German Fuji-5's output, operating in the 20.0 to 27.9 MHz frequency range. It provided 10 preset channels with crystal-controlled stability. The dual BC-603 receivers in the SCR-508 allowed commanders to monitor multiple frequencies simultaneously, a capability that would prove decisive in combat. The real revolution lay in frequency modulation itself. Edwin Armstrong's FM technology, licensed to the military, eliminated the static and interference that plagued amplitude modulation systems. While German tank radios picked up every electrical discharge as noise, American FM radios delivered clear voice communication even during artillery barrages. On November 8, 1942, Operation Torch brought American armor to North Africa. The 2nd Armored Division's tanks landed near Safi and Fedala with SCR-508 radios that would soon demonstrate their superiority over German communications. The Afrika Korps, despite being the Wehrmacht's most experienced armored force, operated under severe communication limitations. A standard German tank platoon of 5 vehicles included only 1 or 2 with full FUG-5 transceivers capable of both transmitting and receiving. The remaining tanks carried Fuji-2 receivers only. They could hear orders but couldn't respond or report enemy positions. German tank platoons functioned through rigid hierarchy. The platoon leader transmitted orders that subordinate tanks acknowledged through actions rather than words. When command tanks were destroyed, easily identified by their multiple antennas, entire platoons lost coordination. This vulnerability would prove catastrophic against American forces, where every tank could assume command functions. The Battle of Kasserine Pass, February 14th to 24th, 1943, provided the first major demonstration of American radio superiority. Though tactically a German victory, the battle revealed capabilities that stunned Wehrmacht observers. During the confused fighting, scattered elements of the UIS 1st Armored Division maintained coordination across 50 miles of battlefield. Tank crews who had never met coordinated attacks warned each other of threats and called for artillery support through crystal-clear FM communications, German signals intelligence units intercepted American transmissions and noted exceptional clarity and coordination. The 10th Panzer Division's intelligence section reported that American units maintained communication at ranges where German radios produced only static. More disturbing was the realization that every American tank appeared capable of full transmission, not just command vehicles. The German FUG-5 radios, operating on amplitude modulation in the 27.0 to 33.3 MHz range, suffered from fundamental limitations. The 10-watt transmitter struggled to reach 2 to 3 kN in ideal conditions, dropping to mere hundreds of meters when vehicles were moving. Every spark plug firing, every electric motor, every track movement generated interference that AM systems couldn't filter. September 1943 brought American armor to Italy, where mountainous terrain should have negated radio advantages. Instead, FM technology proved even more valuable in conditions that rendered German AM radios useless. The SCR-508's frequency modulation handled the multipath interference of mountain valleys far better than amplitude modulation. American tanks coordinated movements through terrain where visual signals were impossible, and German radios failed completely during the advance toward Cassino. American armored units demonstrated capabilities that defied German understanding. Tank platoons separated by ridgelines coordinated attacks with precision that German doctrine said required visual contact. The 1st Armored Division's after-action reports described routine coordination at distances where German radios produced only static. On June 6, 1944, as Sherman tanks rolled off landing craft at Normandy, their SCR-508 radios maintained contact with Naval Fire Support EE, coordination impossible with German technology. But the hedgerow fighting revealed a critical gap. Tank radios couldn't communicate with infantry radios operating on different frequencies. The infantry's SCR-300 operated on 40.0 to 48.0 MHz, incompatible with the tank's 20.0 to 27.9 MHz range. This communication gap proved deadly in the bocage, where German infantry with Panzerfausts could approach American tanks while nearby American infantry had no way to warn them. American innovations solved the problem within weeks. Tank crews mounted EE-8 field telephones in ammunition boxes welded to tank exteriors, wired directly to internal communications. By Operation Cobra in late July, this simple modification revolutionized tank infantry cooperation. From July 25th to 30th, 1944, Operation Cobra demonstrated the full potential of American radio superiority. The 2nd Armored Division, commanded by Major General Edward H.1 Brooks, coordinated over 200 Sherman tanks through radio networks that enabled unprecedented battlefield control. German defenders from the Panzer Lehr Division faced an enemy that seemed to possess supernatural awareness. American tanks responded instantly to threats reported by other units miles away. Artillery strikes coordinated through tank radios arrived within minutes of target identification. The contrast with German capabilities was stark. Panzer Lehr, once Germany's premier armored division, had been reduced to communication poverty. Foe's tanks operated without radios, depending on visual signals in terrain where visibility rarely exceeded 100 km/s. The few functioning radios suffered from interference and limited range that prevented effective coordination. The irony was profound. Germany had pioneered radio use in armored warfare. Heinz Guderian, the architect of Blitzkrieg, had insisted on radio equipment in tanks since the 1920s. His book Achtung, Panzer, published in 1937, emphasized communication as essential to armored operations. Guderian had developed radio communication systems that enabled tank officers to coordinate attacks. He understood that rapid armor advances required reliable communication. Yet by 1943, German tank production couldn't provide the radios Guderian's own doctrine demanded. German production statistics revealed the crisis. In 1943, Germany manufactured approximately 5,700 medium tanks, but fewer than 2,000 FUG transceivers. Many radios went to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment. Soviet tank forces suffered even worse communication poverty. The T-34, despite being the most produced Allied tank, typically entered combat without any radio equipment. Soviet doctrine relied on flag signals and pre-battle planning, with catastrophic results against German forces in 1941. By 1943, Lend-Lease provided some relief. American radios, including SCR 508 sets, equipped Soviet command tanks, but even by war's end, only about 25% of Soviet tanks carried radios. The comparison highlighted American achievement. While the Soviet Union struggled to equip 1/4 of their tanks with any radios, America achieved 100% deployment of sophisticated FM systems. Motorola's Chicago factory represented American industrial mobilization at its peak. Before the war, the company manufactured car radios. Converting to military production required complete retooling and solving unprecedented technical challenges. Each SCR 508 required 2,748 individual components manufactured to exacting standards. The BC604 transmitter contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability despite temperature extremes and combat vibration. Production statistics told the story of American industrial might. 1942, 3,800 SCR 508 family radios. 1943, 11,400 units. 1944, 24,000 units. Total wartime production, over 50,000 tank radio sets. This production miracle ensured that all 49,324 Sherman tanks manufactured during the war received sophisticated radio equipment, an achievement no other nation approached. The SCR 508's advantages went beyond simple frequency modulation. Crystal-controlled frequency stability meant tanks could preset channels before battle and maintain alignment despite combat conditions. German Fuji-5 radios, using variable capacitor tuning, constantly drifted off frequency. The dual receiver configuration allowed commanders to monitor their platoon net and company command net simultaneously. Orders flowed down the chain of command instantly, while commanders maintained awareness of subordinate situations. The BC606 intercom system integrated seamlessly with the radio, allowing all crew members to alert the commander to threats. Throat microphones and noise-cancelling headphones enabled clear communication during combat. Many German tanks lacked intercoms entirely, forcing crews to communicate by touch or shouting. Power management provided another American advantage. The SCR 508 operated on either 12 or 24 volts, automatically adjusting to available power. The dynamotor power supply provided stable, filtered power that eliminated electrical interference. German radios, powered directly from vehicle electrical systems, picked up every spark as static. The tactical advantages of universal radio deployment transformed American armored doctrine. The combat command structure, flexible task forces organized for specific missions, depended entirely on reliable communications. American commanders could create ad hoc battle groups from different units, confident they could coordinate through compatible radios. This flexibility baffled German commanders, accustomed to rigid organizational structures necessitated by limited communications. During the Battle of Aracourt in September 1944, the 4th Armored Division faced multiple German Panzer brigades equipped with superior Panther tanks. The Germans had every advantage in armor and firepower, but American radio coordination proved decisive. Every Sherman could report enemy positions instantly. Tank destroyers received targeting information from tanks they couldn't see. Artillery observers in Sherman command tanks called in devastating barrages within minutes. Over 3 weeks, the 4th Armored destroyed 281 German armored vehicles, while losing only 41 Shermans, a 7.1 kill ratio that defied technical specifications. Throughout the war, German intelligence failed to grasp the significance of American communication superiority. Combat reports mentioned American coordination, but attributed it to training rather than technology. A captured September 1944 intelligence assessment stated, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." The report completely missed the technological advantage. German tactics never adapted to American capabilities. They continued targeting supposed command tanks based on antenna configurations, not realizing every Sherman could coordinate battlefield responses. They planned ambushes assuming American tanks would lose coordination when separated, not understanding that radio contact maintained unit cohesion regardless of visual contact. In March 1945, as American forces approached the Rhine, their communication superiority reached its zenith. The capture of the Remagen Bridge demonstrated the speed of American command and control. When the 9th Armored Division discovered the Ludendorff Bridge intact, radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the entire front were shifting to exploit the opportunity. German forces, dependent on telephone lines that American aircraft systematically destroyed, couldn't respond with comparable speed. American radio coordination created an impenetrable defense of the bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating fires through radio networks. German counterattacks, poorly coordinated due to communication failures, arrived piecemeal and were destroyed in detail. In April 1945, the encirclement of the Ruhr pocket demonstrated the culmination of American communication superiority. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio communications. Inside the pocket, 325,000 German troops found themselves trapped, partly because their communications had collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes. Wehrmacht units lost contact with higher headquarters and with each other. Field Marshal Walter Model's final messages before communication failure revealed the German plight. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. American radio superiority profoundly affected the psychological experience of tank warfare. American crews fought with the knowledge they were never alone. Even when physically isolated, they remained connected through radio waves. German tank crews experienced the opposite, profound isolation. Unable to communicate, they fought individual battles within larger engagements. Otto Carius, one of Germany's most successful tank commanders, wrote in his memoir, Tigers in the Mud, about the challenges of limited communications, though he focused more on tactical aspects than the communication gap itself. The strategic implications extended beyond individual battles. American advances in 1944-45 maintained tempo partly through radio coordination that German forces couldn't match. The Third Army's race across France depended on radio networks that maintained control across hundreds of miles. German commanders consistently underestimated American capabilities because they couldn't conceive of the communication superiority Americans possessed. Heinz Guderian, in his role as Inspector General of Armored Troops, recognized the problem but couldn't solve it. In a December 1944 memorandum, he acknowledged that American coordination negated German advantages in tank quality. After Germany's surrender, American technical intelligence teams evaluated German equipment. Their findings confirmed what combat experience suggested. German tanks often possessed superior armor and armament, but catastrophically inferior communications. U.S. Army Technical Intelligence Report No. 176 concluded that German tank communications equipment was approximately 5 years behind American systems. The absence of frequency modulation, limited radio distribution, and poor electrical suppression created critical vulnerabilities. Soviet evaluators reached similar conclusions. The Red Army, given access to captured German equipment, chose to copy American radio designs rather than German systems for post-war development. Production and deployment statistics reveal the magnitude of American achievement. American radio production. SCR 50A, 528, 538 radios produced 50,000 plus units. Sherman tanks produced 49,324 units. Radio deployment rate 100%. Transmission power 25 WBV. Frequency stability, crystal controlled TU plus 0.01%. Range moving 7 ME. Range stationary 10 to 15 MNO. German radio production, FUG 5 transceivers produced, approximately 6,000 units. Medium, heavy tanks produced, approximately 12,000 units. Full transceiver deployment rate, approximately 20%. Transmission power, 10 W. Frequency stability, variable, plus 1%. Range moving, 0.5 to 1 mile. Range stationary, 2 to 3 miles. Communication effectiveness, average time for American fire mission, 3 to 5 minutes. Average time for German fire mission, 15 to 30 minutes. American tanks achieving coordination, 100%. German tanks with full communication, 20%. The radio superiority of Sherman tanks established principles that govern armored warfare today. Modern main battle tanks carry communication suites that trace their lineage directly to the SCR-508, digital rather than analog, but fundamentally based on universal deployment and reliable coordination. The German Bundeswehr, rebuilt in the 1950s, prioritized communications based on World War II lessons. Every Leopard tank manufactured has carried comprehensive radio systems. A Bundeswehr training manual explicitly states, "The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority." Modern conflicts validate this lesson. In the 1991 Gulf War, coalition forces with superior communications destroyed Iraqi forces equipped with individually superior Soviet-designed tanks but inferior radios. In 2003, American forces again demonstrated that network-centric warfare defeats platform-centric warfare. The story of American Sherman tank radio superiority represents a victory in the electromagnetic spectrum that proved more decisive than advantages in armor or firepower. German tank crews fought their war partially blind to this revolution, discovering too late that every Sherman tank was not just a fighting vehicle, but a node in history's first battlefield network. The SCR-508 radio transformed the M4 Sherman from an adequate medium tank into a component of a weapons system that included every other American tank on the battlefield. This transformation proved more decisive than any improvement in armor or firepower could have achieved. Every Sherman tank carried the tools of victory, not just in its 75mm gun or sloped armor, but in the 181 all-LB of radio equipment that connected its crew to every other American tank crew. This connection created a collective intelligence that no individual German tank, regardless of superiority in armor or firepower, could match. German forces discovered this reality through bitter experience at Kasserine Pass in Italy's mountains across France's hedgerows, and in Germany's final battles, where American tanks demonstrated coordination that German doctrine said was impossible without visual contact. The Wehrmacht never developed an effective counter because they never fully understood the technological gap. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender in May 1945, "We knew how to build better tanks, but you knew how to make them work together," captured a fundamental military truth that would echo through the decades that followed. Whether accurately quoted or apocryphal, these words crystallized what German commanders had learned through bitter experience across every theater of war. America hadn't simply manufactured 49 324 Sherman tanks between 1942 and 1945. They had constructed 49,324 interconnected nodes in what would become the world's first true armored battlefield network. Each tank wasn't just a weapon platform. It was a communication hub, an intelligence relay, a coordinated element in a vast distributed system that operated with a collective awareness the German military never achieved. The revolution in military affairs that modern historians identify with 21st century network-centric warfare didn't begin with satellites, GPS, or digital computers. It began in the North African desert in 1942, when the first Sherman tank equipped with an SCR-508 frequency modulation radio entered combat against Rommel's Afrika Korps. From that precise moment, the fundamental calculus of armored warfare transformed irrevocably. The principles of war themselves had shifted beneath the treads of those American tanks. Superior weapons would fall to superior coordination. Advanced engineering would lose to advanced communication, The network would systematically defeat the platform, and the connected would methodically overcome the isolated, no matter how thick their armor, no matter how powerful their guns. This transformation occurred almost entirely invisible to German forces throughout the conflict. Wehrmacht commanders witnessed American tactical superiority on countless battlefields. The uncanny ability of American tank units to concentrate force at decisive moments, to exploit German weaknesses before reinforcements could arrive, to coordinate complex maneuvers across terrain that should have prevented such coordination. They saw it, documented it in after-action reports, discussed it in command briefings. But they didn't recognize its technological foundation until far too late in the war. German intelligence officers attributed American coordination to superior training, to overwhelming numbers, to tactical doctrine, even to luck. They analyzed American battle tactics exhaustively, searching for patterns they could counter. They studied captured Sherman tanks, measuring armor thickness, examining gun mechanisms, testing engine performance. They found a tank that was, by most measurable standards, inferior to their own Panther and Tiger designs. What they failed to discover, what their analysis framework wasn't designed to reveal, was that inside every single Sherman, mounted securely above the assistant driver's position, sat a technological advantage more decisive than any gun or armor could provide. By the time German tank commanders finally understood that every American Sherman possessed communication capabilities that most German tanks fundamentally lacked, that American platoon leaders could coordinate 5 tanks with the clarity and immediacy that German company commanders couldn't achieve with 50, the strategic outcome of the war was effectively decided. The industrial capacity that allowed America to install an SCR-508 or SCR-528 in every tank rolling off the assembly line had created an asymmetric advantage that no amount of German tactical brilliance or engineering superiority could overcome. The German military's systematic failure to recognize and adapt to American communication superiority stands as one of World War II's most consequential intelligence failures. It wasn't a failure of data collection. German forces captured American radios, interrogated American tank crews, analyzed American tactical communications procedures. It was a failure of conceptual understanding, an inability to recognize that the nature of armored warfare itself had fundamentally changed. Despite thousands of battlefield encounters across North Africa, Sicily, Italy, France, and Germany itself, encounters that consistently demonstrated devastating American coordination advantages, German leadership never prioritized solving their critical communication deficiency. Resources flowed to bigger guns, thicker armor, more powerful engines. The Panther tank received continuous improvements to its already superior firepower and protection. The Tiger II became a nearly invulnerable fortress on tracks. But German tactical radio production never achieved the scale or standardization that American industry accomplished almost effortlessly. German tank crews continued entering battle with communication systems that would have been inadequate in 1935, let alone 1945. They continued building technologically superior tanks that fought as isolated individuals, while American forces fielded adequate tanks that fought as coordinated teams and won consistently and decisively. The mathematics of this advantage was brutal and inescapable. A German Panther tank might destroy 3 or 4 Shermans in direct combat before being overwhelmed. But those Shermans coordinated their approach, shared targeting information, called for artillery support, and requested airstrikes, all through radio networks the Panther couldn't access and sometimes didn't even know existed. The superior German tank died not to superior American armor, but to superior American information flow. In the final accounting of World War II's technological achievements, the electromagnetic waves transmitted by SCR-508 radios proved more strategically powerful than the armor-piercing rounds fired by German 88-meter guns. The ability to coordinate force application, to share tactical intelligence instantaneously across an entire battalion, to fight as a unified organism rather than as a collection of individual vehicles, this invisible advantage determined victory more surely and more consistently than any visible superiority in armor thickness or armament could achieve. The Sherman tank's communication superiority didn't just help America win World War II, it fundamentally changed warfare forever, establishing an iron principle that would govern military competition for the next 8 decades. In modern combat, connection equals survival and isolation equals defeat. Information dominance trumps material superiority. The force that can see the battlefield most clearly and coordinate its response most rapidly will defeat the force with better individual platforms every single time. German tank crews discovered this brutal reality on battlefields across 3 continents, from the deserts of Tunisia to the hedgerows of Normandy to the forests of the Ardennes. They learned, far too late to change the outcome, that the Americans possessed not merely numerical superiority, though they had that too, but technological superiority in the dimension that mattered most in modern mechanized warfare. The ability to fight not as individual tanks, but as one collective force, aware and responsive and unstoppable. That invisible advantage, transmitted through frequency-modulated radio waves at 25 watts of power, decided the war as surely as any bomb or bullet ever fired,